You know when you see one of those massive, brilliant LED screens lighting up a city square? It's easy to just be amazed by the final product. But today, we're going to go behind the curtain, behind the screen, to really dig into the critical safety systems that make these installations possible. We're talking everything from the individual worker all the way up to the tech itself.
Right. Take a look at this. It's beautiful, it's captivating, but what you're not seeing is the story of how it got there. You don't see the crews working at dizzying heights, dealing with high-voltage equipment. These things aren't just giant TVs, you know. They are serious structural and electrical engineering projects, and believe me, the stakes are incredibly high.
So, how do you even begin to manage all those risks? Well, it all boils down to this really powerful idea: prevention through design. The concept is actually pretty simple, but it's profound. Instead of waiting for hazards to pop up on site and then reacting to them, you design them out of the system from day one. It's all about building safety right into the blueprint, not just slapping it on as an afterthought.
Okay, so our journey into safety has to start where it matters most, with the individual worker. This is, without a doubt, the first and most fundamental line of defense on any job site.
First up, personal protective equipment, or PPE. This is the absolute non-negotiable gear for every single person on site. We're talking the basics, like helmets for falling debris and anti-slip shoes to keep your footing. But it gets way more specific. For anyone working near high-powered electrical boxes, arc-related clothing is a must. And this isn't just any old fire-retardant shirt. It's specifically designed to protect you from an arc flash, which is a violent, incredibly dangerous electrical explosion.
And this is where that whole prevention through design idea gets really personal. It literally applies to the worker's body. Good ergonomics don't happen by accident. See, these structures are engineered with safe access routes and stable platforms for a very specific reason, so maintenance crews can do their job without twisting or overreaching in some dangerous way. It's about preventing injuries before they even have a chance to happen.
All right, let's zoom out a little. We've talked about the individual, now let's look at the environment they're working in. I mean, working at heights is one of the biggest risks in any construction project, and LED installations are definitely no exception.
75 degrees. Remember that number. It might not sound like much, but it can be the difference between a secure ladder and a trip to the hospital. It is the perfect angle for placing a vertical ladder. Any steeper and you risk it tipping right back on you. Any shallower and the base could slide out from under you. It's a simple rule of physics that honestly saves lives.
Now, this cartoon might look a little silly, but it highlights some critical mistakes that happen way too often. Rule 1, never ever move a ladder when someone's on it. And Rule 2, one person per ladder. That's it. These aren't just friendly suggestions from a manual. They are fundamental life or death safety rules.
Okay, let's talk scaffolds. They give us more room to move around, but they come with a whole new set of risks. So let me ask you this. What do you think is the absolute #1 rule when you're working up on a scaffold? I'll give you a hint. It's not about what you're wearing.
The answer? It's all about controlling what's around you. A dropped wrench from that height can become a lethal weapon. So the #1 rule is that nothing, and I mean nothing, gets left unsecured. Every worker has to use a tool bag, and at the end of every single work session, that scaffold is completely cleared. A clean platform is a safe platform, not just for you, but for everyone below. And this whole idea of control then expands out to the entire site. We're talking physical barriers like fences and really clear warning signs. During the super risky stuff like heavy lifting, you need dedicated monitors whose only job is to keep unauthorized people out of the area. Even the temporary stuff has strict rules. Scaffolds can't go higher than 6 meters without extra support. And all of this has to rest on a rock-solid foundation, sometimes needing concrete pillars that are a full meter cubed. Okay, we've covered the worker and we've covered the workspace. Now we need to tackle the hazards that are baked right into the technology itself. These displays use a ton of power, and that creates some major electrical and fire risks that have to be managed carefully.
Let's talk about one of the most important safety protocols out there, lockout/tagout, or LOTO. It's a formal, step-by-step procedure to make sure a piece of equipment is completely powered down before anyone works on it. Step 1, isolate all the power sources, and that includes any backups. Step 2, put a physical lock and a tag on the circuit breaker so nobody can accidentally turn it back on. Now, Step 3 is the one that people often miss, but it's the most critical. You have to verify. You take a voltage tester and you prove that the circuit is dead before you touch anything.
Fire prevention is tackled from 3 different angles. It starts with the actual materials. All the plastics have to have what's called a V0 flammability rating.
In simple terms, that means if you set it on fire and remove the flame, the material has to put itself out within 10 seconds. Then you use technology, like infrared cameras, to scan for hot spots that could signal a problem. And finally, you need access. A big, obvious emergency fireman switch has to be installed, letting first responders kill all power to the display in a second.
So, we've looked at the different pieces: the person, the place, and the power. Now let's pull it all together and see how these parts integrate into one complete safety system, one that's governed by official standards.
Now, in the United States, you'll hear about two key organizations, OSHA and ANSI. It is so important to know the difference. OSHA regulations, that's the law. It's mandatory, and if you don't follow them, there are legal consequences. ANSI, on the other hand, provides voluntary standards. They're what we consider best practice. And while they aren't legally required, ANSI standards are often way more detailed and up to date. A truly safe site follows OSHA's laws, but it uses ANSI's guidelines to really aim for the highest level of safety possible.
It's also crucial to understand that not all safety measures are created equal. This is the hazard control hierarchy, and it shows you the most effective way to manage risk. Right at the very top is elimination. That's designing the hazard out of the project completely. That's our prevention through design principle. But now, look what's at the very, very bottom: PPE. Your helmet and your safety glasses are the absolute last line of defense. They're only used when a hazard can't be removed by design. It's a total shift in how you should think about safety.
And that really brings us to the ultimate takeaway here. Real safety isn't a manual that sits on a shelf collecting dust, or some checklist you mindlessly tick off. It's an active process. It's a core part of the design that's engineered into every weld, every single wire, every workflow. So I'll leave you with a question to chew on. In your world, is your safety plan just a document you file away, or is it a core part of the design you actually build?